Good morning. I'm Shannon Bay, the Program Manager of Adult and Community Engagement here at the museum. There's my video. And we are thrilled that all of you are here this morning to join us for this awesome talk. So before we get started with the program, if you haven't done so, please introduce yourself in the chat box. Many of you have, and we're thrilled to have so many people joining us from around the world. We are really just overwhelmed with the response we've gotten for these talks. So thank you for tuning in. And to find the chat, if you're not sure where it is, so if you look down here at the bottom of the screen, if you hover your mouse over it, it might not appear right away, but when you hover your mouse, you'll see a little chat and you select that and then the chat box will pop up on your screen. So again, please introduce yourself. We'd love to know where you're tuning in from. And please also utilize the chat box throughout the talk for questions, and Dale will answer those at the end of the talk. So, and also today, I would like to welcome our museum members who are with us today. Your support made this event possible. If you're not a member yet, please consider joining the museum or making a charitable donation, and you can go to gokm.org to become a member. So now to introduce our speaker, Dale Kronkright. Dale has served as the head of conservation at the Georgia O'Keeffe Museum since its inception in 1997. To preserve O'Keeffe's artwork for generations to come, Dale has developed a variety of scientific inventions, such as micro-environmental framing systems and special light filters in collaboration with the Getty Conservation Institute in LA and the University of Texas at El Paso. Today, Dale will be sharing with us the museum's conservation assessment of O'Keeffe's Abiquiu home and studio and the challenges facing us in preserving this historic structure. So please welcome Dale.
Thank you, Shannon. Greetings, everybody. This is so exciting that despite circumstances, we can still do this. So I'm gonna share my screen here and we can get started. Great. So, the title of the talk today is Discovering the Challenges, and that's an important word because our conservators, such as myself, are always on an adventure of discovery. I mean, most often we're trying to discover damage or deterioration, the cause of damage and deterioration. We might be trying to discover the original materials that the artist used, the studio techniques. It is an amazing adventure. For conservators most of the time, and we love telling that story of discovery. But this story is a little bit more complex because when the art object that we're looking at is as big as a house and a studio and a garden built on top of a hill with precipitous drop to the valley below, when it's constructed and maintained by a whole community of people, and it's got a mix of handmade traditional materials and mail order materials. It's a really complex object, if you will, to look at. And it really takes a team of people to come together to bring their considerable skills and their considerable knowledge and try and go on this journey of discovery together as a team. And that's really what this talk is all about. The house and studio, we have to remember, has been sitting outside in the elements 365 days a year for 71 years. And the artist herself continued to make changes and evolve the building, adding windows, adding fireplaces, changing finishes inside and out. So there really is a lot to discover here in terms of the tangible materials of the home and studio. But the team also had to think about and discover many of the intangible properties. That is, not only what the house and studio and landscape is tangibly, but what it does for people intangibly. And that really is a wonderful part of the discovery too. understanding that the house and studio is a part of the Abiquiu community. The property was there long before, obviously, O'Keeffe got there. It was there as part of the Pueblo ancestral use of the land. It became a part of the Spanish colonial part of the history of Abiquiu, and then as the historical part of the Abiquiu. So it has a long history, and it means a lot to both the Abiquiu community as a place and as part of their heritage, and the entire Chama River Valley as well. So we have to understand that. We have to understand what the property does and means to O'Keeffe, and how she used it, why she designed it the way she did, as a place where she could really concentrate on her ideas, on her work, making it as efficient as possible, and also what it meant to her family and her friends, neighbors who visited, who came for dinner, and so on. So there are a lot of intangible values that the property represents that we're trying to preserve as well. So as you can imagine, as you get the impression, this is a very complex endeavor. And it took a lot of sophisticated people with a lot of sophisticated contemporary equipment. You have to remember, one of the big challenges is that in 1959, George O'Keeffe found it very difficult to keep maintaining the mud plaster finish that she had originally put on the entire property. 1958 was an extremely rainy year. It had washed the finish off many, many times. And she was having a hard time finding enough people to help her reapply the mud plaster to the exterior of the building, and decided that she would just have to do exactly what she had done up at the Ghost Ranch property, which would be to cover the exterior with cementatious stucco. The difficulty here is that what that means is that O'Keeffe covered all the surfaces that we need to look at to assess the condition of the structure, the condition of the adobes, the condition of the walls and the windows. All that has been covered with cement stucco, and we can't see it. So this group had to come up with some sophisticated instrumental ways of looking through that cement shell, if you will, to try and understand the condition of the adobes underneath. And that was a big part of the challenge. So what I'm saying essentially is that this was a huge effort, and we could not have done it without sizable financial support. And we're going to start out today by thanking the people who really believed in this project, believed in this journey of discovery, of trying to understand how we can safely go about preserving this incredible site and this incredible structure. But first of all, hats off and thanks to an anonymous foundation who made the initial gift of support, along with the Stillwater Foundation and the National Park Service. These are organizations that clearly saw the value of this property, of O'Keeffe's story, and the preservation of this property for generations to come, and we thank them. I also want to thank, as Shannon did, the members of the George O'Keeffe Museum. Our director, Cody Hartley, said recently in a conversation that we had that the members inspired him to do what we do and what he does. And I think that's absolutely true. Knowing that you all are out there in the midst of this virus and everybody trying to cope with this, and excited to learn about the property, the conservation assessment, the preservation challenges that we face together, is inspiring. It is why I do what I do. Knowing that if I can truly uncover some important information, some great ties, connect the patterns, you'll be there to share it. So I want to thank our members, and I want to encourage those of you, if you're inspired by this journey and you're not members yet, please join us, because we'll have many more adventures just like this one. So I'm going to introduce the team just sort of visually and show you all the people, the main people who were involved in this. On the left hand of your screen are the George O'Keeffe Museum staff members who participated in this. But in particular, I want to point out this person. This is Stephanie Wilson, the Collections and Interpretation Project Manager. And the fact is, I'm going to dedicate this talk to Stephanie because we could not have brought together more than 20 individuals, all being on site when they needed to be on site with the gear they needed to be there, getting their gear to Santa Fe, being present for meetings, in person and virtual, putting all the components of the study together, doing the interpretation. None of that would have worked without Stephanie's great work. So, Steph, this talk's for you. This is the assessment team, the main group of contractors that we brought in. So in the picture there, you'll see Pamela Hawks, who was our principal historic architect and co-leader of the project. Also, Michael Henry is taking a picture of the window frame there. So Michael is our conservation engineer. We assembled our working drawings and our understanding of the interaction between the different components, thanks to the efforts of this man, Peter Oslestad. And Peter takes photogrammetry and laser scans of the entire property, inside and out, and built for us a virtual high-resolution 3D model from which he was able to then do plans, sections, and elevations of every component of the building, inside and out, including furnishings, cabinets, and all the built-ins, from which we could then make our notes. And Peter's work, honestly, is the best I have ever seen in my life. So Peter, hats off. So this is Dorothy Kreutzer, who runs Building Conservation Associates. And Dorothy is a conservator of architectural works, and she was doing our survey of all the finishes, inside, outside, walls, floors, ceilings, stucco, and mud plasters. We'll see more of Dorothy's work soon. And then last but not least, these two wonderful people who I've become close friends with, Tony Crosby in the orange shirt there and the measuring tape, who is our Adobe conservator, and Dave Woodham, who is our structural principal engineer on the project. Great team members. And then there were consultants that also worked on the project, and I just want to briefly mention and thank them. Jonathan Craig, architect in Albuquerque, who's working on the historic structures report with Ed Bowles. Sarah Rovang, our architectural historian, who did a tremendous amount of research, not only in the O'Keeffe archives, but also at the Beinecke Library at Yale. Julie McGilvery, who's our landscape architect, who's doing the cultural landscape report. Bohannon Houston Engineers of Albuquerque, who did the topographical survey and got resolution down to the half foot for the entire property, the entire site. Geotest of Santa Fe, who did our soils testing, our subsoils testing, gave us a great deal of information about the hydrology of the project. And then Ed and Jess Crocker, who were our Adobe contractors, who helped us open and close windows in the surface and help us with their expertise as well. So you can see it's an enormous team brought together to try and understand what the history of the structure was, the kind of deterioration, damage, and alterations by O'Keeffe that occurred over time, and how we can best preserve those. So what were some of our goals? Well, obviously we want to document the site context and the soils, the hydrology, the surface drainage, landscape, all the things that contribute to what the site is tangibly, what it means intangibly, and how the whole system interacts from a preservation standpoint. We obviously want to assess the long-term stability of those adobe walls and the impact of the cementatious stucco shell that's on the outside. And that was a major challenge because we couldn't see the adobe walls for the most part. We want to review the condition and the capacity of these very large openings that O'Keeffe designed into the structure. Remember, she took a 19th century Southwest adobe structure, and she made it a modern architectural work. And part of that was including very large windows, 16-foot wide spans of glass in her studio and other places that we'll see. And those walls with those large openings, for the most part, are supporting at least half of the roof load on top of them. So the question was, what's holding that up? What's holding that load? And is there fatigue? Is there deflection in those supports that might be endangering those glass openings? And we want to consider the impact, the increased visitor flow that we're now having as we provide more and more tours of the surface, and the effect of people, large numbers of people, on the historic finishes. The building was only meant to support the life of an artist, her family, her friends, and her support staff. And we're doing much more than that. So we really need to know what that's doing for the preservation. And we needed to find and determine how to use some new non-destructive or minimally destructive methods for getting underneath that shell and assessing the condition of the adobe walls. And finally, we wanted to provide recommendations for the long-term monitoring of the building and assessing and monitoring its condition so that we can address deterioration before it becomes a major problem. Briefly, how we did that with methods is kind of this list. So obviously a great deal of historical analysis took place. Pamela Hawks did a great deal of historical analysis within the O'Keeffe Museum Research Center and Archive, went through historic photographs by Maria Chabot, the early drawings, the correspondence between the two, and began to come up with a chronology of construction and how Maria Chabot managed to put the entire thing together from the moment that George O'Keeffe acquired the property in 1945 to when it was finally finished and O'Keeffe moved in full-time in December of 1949. Sarah Roving, our architectural historian, also contributed to that effort. And then there was dimensional analysis, as I mentioned, the topographic survey, the laser scanning and photogrammetric 3D imaging, measuring the plumb and dislocation of all the adobe walls. This is a handmade structure. These are not industrial materials. Every wall is handmade out of handmade components, and so there are lots of curves and undulations that need to be analyzed. Obviously, visual analysis of the entire team on the site. Environmental analysis was key. So we put up a major weather station on the site so that we could begin to measure in real time the total energy of the storms that go through the site, summer and winter, along with full monitoring of all the rooms using data loggers so that we understand the environment that's going on and how the building responds to environmental changes. And then some non-destructive testing. We did soil borings around the site to understand what the hill is that the building is sitting on, what it's made of, how stable it is, what the soil levels are, and what the hydrology is. We did infrared thermography, so measuring the temperature and the moisture content of walls inside and out using thermal imaging and trying to get an understanding of how the exterior cement shell of stucco is informing the preservation of the site. Surface penetrating radar to understand what's above those windows, moisture meter readings to understand how soil moisture in particular, is interacting with the sensitive adobes, fiber optic video scopes, and then crack monitors, moire and grid telltale crack monitors that help inform us how walls might be moving in response to temperature changes and soil moisture changes that are affecting the preservation of the site. We also had a few selective destructive methods. So we did manual resistance drilling, and that is literally taking a 1/2 inch spade drill and going through the stucco, forming a hole, and then measuring the resistance as you go through that area and sort of getting a feel for where there is solid material behind that, how dense the adobes are. And then we tried a brand new technique, thanks to Dave Woodham. He got a resistograph, essentially, which is a very small 4mm spade drill that's inside a contained gun that forces the drill through at a known rate. And then it measures the resistance as it goes through and measures the density of the mud plaster, of the adobes, over about a 30-centimeter area, or about 12 inches, to measure the density and strength of the adobes at different areas. So this is a very small hole, and we get a great deal of data. And this is a brand new technique that's never been applied to adobe structures. So this was pretty terrific. And then we also did some stucco removal and opening of visible windows in areas that seemed to be very problematic, so we could get a closer understanding of what was going on. And then, of course, we also did survey level assessment of all the historic finishes, walls, floors, ceilings, exterior and interior. So let's take a look briefly at the historical analysis and take a look at what George O'Keeffe and Maria Chabot got in 1945 when they first acquired the property and began thinking about how this might work as a studio artist residence and studio and garden. So what we're looking at here is what's known as the lower bedroom. And what I want to point out is, of course, that there's been a lot of erosion of both the adobe plaster and the adobes themselves. The vigas that hold up the roof are sitting right on top. There's no parapet there. So these were very, very low ceilings initially. We want to be aware of that. But in particular, I want you to note that the trench and rubble foundations for these adobe walls have been largely undercut. And in this case, this portion of what became the lower building, the lower bedroom, has got some problems, not the least of which are some major cracks. So if we follow a crack right down over the left-hand side of this door and go down to the foundation, what becomes clear is that the left-hand side of the room, where there is now a large window, looks to be rather stable and sitting the way it was supposed to, but the lower half of the bedroom seems to have fallen away and literally sort of tilting down, that there's some sinking of the foundation. This kind of makes sense because the flood irrigation of the property came around this front area in here, and so moisture, soil moisture, may have affected the initial foundation of that area. Let's take another look at what is now sort of the kitchen area, the way it was when they first acquired it in 1945, and we can sort of see the same kinds of conditions. That is that these foundation cobbles that you see along the bottom of the structure used to be inside a trench. They used to be below soil level. So there's been a great deal of soil erosion over the years that lowered the soil level of the site itself, exposing the foundation. So that foundation had to be rebuilt. The other interesting thing is that this area right here, where you see this large erosion, this wall is what O'Keeffe termed the Indian room because it had a shepherd's bed on it, and she preserved that room exactly the way it was. And then in this long wall where you see that lintel and window going all the way across, that's now the complex. This is where the door to the kitchen is, and there are a series of very large windows in this space. So building on top of these adobes and on that foundation, they put in some very large windows, and we needed to understand how they were accomplishing that. So this is a look at the south-facing wall and the west-facing wall from what became O'Keeffe's garden. And so we'll sort of point out what we're doing. The top photograph is what it looked like in 1945. The bottom photograph is the way it looked when it was finished in 1949, when O'Keeffe finally arrives full-time. We'll take a look at some of these differences. So this is a sitting room that became sort of O'Keeffe's living room. And notice that there's a very small historic 19th century window at the end of that. And that when they finished it, that small window is still there. Now, those of you who've been to the site understand that that window is now a very large window that takes up the entire wall. That's a major change that O'Keeffe made. Notice there's no fireplace along this wall the way there is now. There's a canale that we can see in the historic photograph that has eroded the mud plaster in that area. And that was a continuing problem. That canale is still there, and it continued to create problems even during O'Keeffe's period. But look how much higher the walls are. Here, the vigas are exposed, and here we've gone way above the window level. And so O'Keeffe and Chabot raised the ceiling height in all the structures. This area right here with this window is what became known as the roofless room, the room that Chabot and O'Keeffe decided not to re-roof and leave as sort of an enclosed open patio. So here's that area right here in the lower photograph. And then here's the lower bedroom where we saw problems in the previous photograph. And what we can see is that there's a window there, and that window still exists in that area. So they left the window there. But what we can see is that the end of that room had completely fallen off. There's another large crack here, again, as if that foundation had completely sunk. What we know is that Chabot and O'Keeffe built a brand new 3-foot deep concrete foundation for the end of that room and built it with this rounded corner, so stabilizing that entire end of that room. But what they didn't stabilize was the bedroom below it, and we think that continues to create some problems, and we'll look at those. Here's that same lower bedroom and the lower bathroom with the curved wall. We're looking at it the way it looks right now from the garden. And what you can see is that there is a continuing crack right at that lower bedroom window that indicates that this portion of the building is absolutely stable and staying exactly where it was meant to be, but that this portion of the building, the lower bedroom itself, does seem to be moving. The entire structure seems to be sinking slightly and may even be raising slightly. So as the ground absorbs moisture and as the clay absorbs and swells, it might be moving those unstable foundations. So we're keeping a close look on that space. There's a closer look at that crack at that window. So it really does, this has been patched many times. It's patched every year, and the crack reappears on this side of the window and goes up. We'll take a look at our crack monitors that we put on the inside of the building at that same area. So here we're going to be looking at the crack monitors called moire crack monitors, literally a moire pattern, and grid telltale crack monitors. So the moire looks like this. There are two halves. You put each half on each side of the crack. There's a pattern that's created by a series of very small circles. The grid essentially does the same thing, but it has a grid with a pair of crosshairs. And when the wall moves, you'll notice that the circular moire pattern that we see when we first install it actually shows not only the degree of movement, but also the direction of the movement. Now, just finishing up the historical analysis, I want to share these three photographs because they tell us a great deal. The photograph on the right is interesting because the workers from the Abiquiu village are mixing mud mortar there and building O'Keeffe's studio. And what they've done is they've taken out a bunch of damaged and unstable original historic adobes, and that's what we see in the foreground. They're brittle, they break, their exteriors that have been exposed to the elements are highly eroded, the inside edges are relatively square. Well, we get an idea of their size, and they were about 16 by 14 by about 4 inches deep. The new adobes that they're using to build the wall in the background are the same adobes that you see in the left photograph. And in the left photograph, we can see the over 22,000 adobes, fresh adobes that were made to raise the additional height on the existing walls and build new walls for O'Keeffe's studio. And those adobes, those 1945, 1946 adobes, are slightly smaller. They're measuring 14 by 10 by 4 inches. The middle photograph, the workers are trenching a new foundation for O'Keeffe's studio on the north side of the property. And this is the traditional way of building these kinds of foundations. You build a trench, you line the trench with large river cobblestones, you pour in mud mortar, the same exact mud that you're using to build the adobes, and then add another layer of stones on top of that, add mud mortar to bind them together, and keep building until you're all the way up just even or slightly above the surface, and then you begin to build the adobe walls on top of that. It might seem foolish initially to think about building a foundation in the ground that's going to receive moisture using mud plaster mortar, but instead of cement, for example. But in reality, it's not, because the by using the same exact mud mortar as the adobe blocks themselves, that's the same material bonding to the same material. And when they dry, the bond is extraordinarily strong and long lasting. So this is fantastic technology that's being used even today. So this is what was delivered by Maria Chabot and George O'Keeffe as O'Keeffe's new home on the Abiquiu Hill in 1949. And I want you to pay attention to some really beautiful features about this. First of all, if you know anything about O'Keeffe's painting, about her sculpture, you know that it's all about precise control of edges and the edges of forms, and boy, this building has it. So we're looking from the garden at the south-facing and west-facing walls again. This is O'Keeffe's sitting room, the roofless room, the lower bedroom and bathroom. And look at the sharp, beautiful edges of the parapets on these buildings. Look at that beautiful sharp edge right at the edge of that form. And the same thing here, looking at the east entrance area, the O'Keeffe's bedroom at this end, the gate, her sister Claudia's bedroom, Vida's bedroom, the Sagwan entry into the courtyard, and her library and book room. Beautiful edges, a nice, sharp, squared parapet all across the top, and these very large windows. It really was a modern building. It wasn't a traditional Pueblo home. It wasn't a traditional Spanish home. O'Keeffe and Chabot had really worked to make it a contemporary modern structure. And that's a pretty interesting thing. Let's look at some of the details of that original mud plaster. This is the famous black door inside the patio that goes into the Salita room where O'Keeffe prepared her canvases, stretched and primed her canvases, and stored her paintings. But take a look at the mud plaster, 1949. It's already weathered slightly since it was put on. It was put on in 1947, 1948. So there's already some weathering, but you can see these kind of circular swirl marks. Let's take a look at the window on the north side of the building. This is the window into the pantry, and you can really see the hand finish of this mud plaster and see those kind of swirl marks. You can even see pieces of chopped hay that are included in that mud plaster. The purpose of this finish, this is a traditional finish, rather than the sort of smooth, silky texture that it takes on later. As water comes down from rain and snow on the parapet and comes down those walls, those handmade, finger-made swirls actually break the water down and move it across the entire surface rather than allowing it to fall as a straight rivulet that would cause a lot of erosion in that surface. So this is a beautiful technique. And of course, the large windows that O'Keeffe put into the structure to really make it modern. This is O'Keeffe's studio. That window that you see there is almost 16 feet long. And notice the vigas of the roof are right on top of that window. So what's supporting all that mass? And is that window in danger of being compressed and breaking? Something we really needed to figure out. There are a number of large windows, not only the studio window that you see there, but also the large window that she put into the sitting room much later, about 1964. We'll talk about that. The large window that she put into Claudia's room with a large adobe mass over that. The complex of windows and doors across the entire wall of the kitchen. Again, the vigas are on top and the entire roof load is sitting on top of that. And her bedroom, where the entire northeast corner is glass. Again, with the roof load sitting on top. And you can see the expanse and how thin that material, that supporting material is, whatever it is. So we needed to figure that out. So here's how we did it. This is Dave Woodham using surface penetrating radar, both on the interior and the exterior, to figure out what exactly is above that wall. And what we found was that there's a large steel member, likely to be a steel I-beam, that Pamela Hawks found Chabot discussing how many men it took to put that I-beam in place so that they could then frame the window. So the large studio window and the windows at the corner of O'Keeffe's bedroom are both supported by steel. All the other windows in the structure are supported by large wood lintels over those windows. And the analysis of the surface penetrating radar as well as the video scope suggests that those supports are essentially laminated 2x12 lumber members that have been joined together with screws and nails to support those loads. The good news is there's absolutely no deflection in those windows, so the windows are under no compression. Well, there has been some erosion of the window sills and the window frames. There's no compression from the roof loads above, and they're incredibly stable. So that's great news. I want to talk briefly about the large window that we have at the end of the sitting room and when that occurred. This is architectural historian Sarah Rovang, who was our historian on the project. And Sarah went to the Abiquiu Library at Yale to try and find some evidence of when this was put in. On the left, you can see a photograph from about 1962. O'Keeffe's been traveling the world. We can see the Turkish flag pillow on the chair almost in the middle of the room. We can see her above the clouds painting on the left-hand side. But the original small historic window is still there, and it's surrounded, of course, by a solid adobe wall that's tied into the east-facing and west-facing walls of the sitting room quite nicely. What Sarah found was the magical receipt that helped date this. So this is a photograph in 1964, and what you can see is that the large adobe wall now is mostly gone, and that end wall is almost all glass. That's created some structural problems that we need to address over the short and long term. Notice that the fireplace that O'Keeffe added into this wall in about 1968, 1969 is not there yet. So this photograph is probably right around 1964. So good work, Sarah. We really appreciate knowing when that window went in and how long it's been there. Let's take a look at the thermal imaging camera because as it turned out, the thermal imaging camera combined with the resistance drilling system that we used and the video scope helped to answer the very complex question of what was going on under that plaster that covered all the walls. So here we are again in the garden. We're looking at the west-facing wall of O'Keeffe's sitting room with that 1968, 1969 chimney and fireplace that's been added in. The canale we had talked about before with a drain underneath it, and this is the roofless room. Now, when we do thermal imaging of this west wall, obviously what we're going to be looking at is the temperature differences in the cement stucco itself. We're not penetrating that really, but the temperature of the cement stucco is going to be dependent on how it's in contact with the adobe mud plaster and the adobe wall directly underneath. So it might give us some picture of what part of the cement stucco is still in good contact with a mud plaster that's in good shape and where it's not. The camera itself looks like this, kind of looks like a normal digital camera, except that the sensor really is only accepting infrared light at a far infrared area that we all know as heat, essentially. And this is what we expect to see in an adobe wall. This is the interior of the sitting room, looking at the east wall, and the temperature range that you see here on the right-hand side indicates that white colors and pink colors are around 75 degrees. Dark blue colors are about 65 degrees. We can see outside the door on the patio, the ground out there is about 75 degrees. There's that white color. This is the target that we're measuring. This is the value of that target, about 67 degrees right at the base of that wall. And that's because this is where the greatest thermal mass exists. We have the mass of the adobe and mud floor. We have the mass of the adobe wall. That mud mass can absorb a lot of BTUs before the surface temperature rises. So we can see where they join, it's coolest. And as you move away from the joint, things start to get warmer and the color starts to get more green and more yellow. That's not what we found on the exterior. And this became the major puzzle. These 4 photographs are a time lapse taken over the course of about 2 hours of the west wall looking from the garden. Notice that in exactly sort of the opposite relationship of the interior of the sitting room, the exterior cement stucco has its hottest temperature, that is the white and pink temperatures, closest to where it meets the ground, where it ought to be coolest. And notice that it's also the slowest thing to cool off. So this is about 20, 30 minutes later. The photograph in the upper right-hand corner is about 30 minutes later from that. And again, about another 30 minutes later here. We do see the parapet at the roof line cooling normally, exactly the way we would expect. But the fact that the greatest amount, the hottest areas of the cement stucco are at the bottom, except for this horizontal line where actually that is where the floor meets the foundation. We have highest temperatures sort of in these spider web patterns as you move up the wall. When we combined these temperatures with surface drilling and resistance drilling, then using the video scope, our questions seem to be answered. What we believe now is that during the winter, when the cement stucco gets extra cold, the moisture, the natural moisture contained in the foundation and in the wall condenses, forming liquid water on the inside of the cement stucco. That liquid water drops just the way it would on the exterior of the cement stucco, and it washes away portions of the adobe mud plaster and even portions of the adobe, and that it forms an insulating air pocket just behind that cement stucco. So what we're seeing here in these thermal images is the cement stucco getting hottest where there's an air pocket behind it where it can't transfer those BTUs to the wall below. This is a brand new technique of understanding the relationship between the cement stucco and its bond to the adobe mud plaster and the adobes below. And it became an extremely important technique that we hope to continue using in the future. Just to briefly look at our dimensional analysis and the incredible work of Peter Oslestad and the 3D imaging. First of all, this is the topo map. There are very fine lines there. This is a resolution of a ½ foot for the entire site. So if you take a look at the site, this area here is O'Keeffe's studio, the entrance, the sort of large parking area that she had, the rest of the building itself, in here around that central courtyard, and then the garden area itself. And this is the hill dropping down into the Abiquiu Valley. So we have complete resolution. We can see where Maria Chabot flattened the top of the hill right here with the bulldozer so that O'Keeffe could have great views looking towards the north out of her large studio window. So we have an exact understanding of the topological surface of the property and the hillside, and we can keep track of the effects of erosion and weathering over time. This is a 3D mesh of the east-facing wall of Claudia's bedroom. And what you're seeing is a series of trapezoids there, taken, built by a number of photographs. So probably 100 photographs here of this same window, each photograph overlapping the other one by about 60%. Software, digital software, is then able to locate the same points, the same details in each photograph and connect them, forming a solid mesh. And this is how Pete Oslestad assembled this beautiful 3D model that I'm going to share with you now. So from the 3D model, inside and outside, and I'm sorry about the resolution of this illustration from Pete, but he was able to then create elevations of every portion of the building, showing the precise thickness of the walls of each part of the structure, the doors, the built-ins, and even the furnishings, because these drawings are actually extracted from the 3D model. So what we're going to look at right now is the 3D model itself. You're looking down as if you were an airplane on the roof of the property. O'Keeffe's studio is here. The Claudia's bedroom, Fida's bedroom, the book room, the lower bedroom here, and the garden here. And we're going to show you what it's like to create a point cloud and what you can do with it. Excuse me a second. Hang on to your hats, because what we're going to do here is that we're going to drop down We're going to take a look at the parking lot, and then we're going to fly through the front gate, and we're going to go into this front courtyard where the garage and auto court, it will be on our left, and O'Keeffe's studio will be on our right. And of course, we all want to see O'Keeffe's studio. That's the most important part. So there's O'Keeffe's studio, and we can see through walls and see details of walls. Let's just go into the studio. You can see the vigas above, the large door, the large window, all the built-in cabinets, O'Keeffe's bed. And then we can look through into O'Keeffe's bedroom. So there's the large corner windows of O'Keeffe's bedroom. We can go on the outside and see the large windows, how they're holding up. All the details of the entire interior and exterior, every undulation in the wall, every undulation in the parapet, the details of the furnishings, the undulations in the floor finishes are all there. We're now in the center courtyard. There's the well with her sculptures on top. We'll go into the sitting room, see the built-in banco, the vigas and the latillas overhead, the large window that she installed. We'll go outside into the garden again, and we can even zoom up and see the exact condition of the roof line. We're going into the roofless room. There's her sculpture. We'll zoom into the kitchen and see the kitchen cabinets, the dishwasher, the stove. Look back into the roofless room, and then we'll shoot back out and take a look at the condition of the exterior roof. This is all done using photography and creating a 3D model. This model then becomes the basis for all of our drawings, all of our as-built present condition understanding of the building itself. So quickly, I want to talk about some of the resistance drilling that we did to complement the thermal imaging and our understanding. So this is the actual sort of gun that moves about 30 centimeters, a small 4mm or 3/16 of an inch spade drill, and measures the resistance or the density of the adobes underneath. Now, I just give you an idea of what that looks like and a little idea what it sounds like. I apologize. It sounds a little bit like the dentist drilling in your teeth. A chart comes out, and that chart is exactly what you see at the bottom. So what we're seeing here is that for the first few centimeters, there's almost no resistance. It's air, and then some dry powder, and then we begin to hit some real dense adobe, going right up to what we consider to be normal density for the adobe. And we're hitting that at about 8 inches into the 14-inch adobe. Still plenty of structural integrity, but with a very small hole. The point here is that we can get a very clear picture of the density of the structural adobes within that wall. And then we complement that once we have the hole with fiber optic video scope, looking at that structure and seeing what's behind it. And what we found is what you see here. So the video scope is able to look straight ahead, look down, look up, look to either side. It's an amazing instrument. So this edge right here is the edge of the interior cement stucco. This is a 1/2 inch gap back to an adobe. What we would expect to see here is mud plaster. We wouldn't expect to see this large gap. And this is what's leading us to believe that condensation along the inside of the cement stucco, when the wall gets very cold, creates the washing away, the erosion of the adobe plaster and the outside surface of this. And this is going to become a very important group of techniques that together will allow us to monitor the entire structure over the long term. Now, there were some areas where we did have to do some stucco removal, and I'm going to show you how that works. So that's Jess Crocker standing directly underneath the canale where we had some very wet adobes at the base of that wall. And when we did our resistance drilling, we found in 2 areas almost no resistance all the way 30 centimeters into the wall. We were very concerned that moisture had worked its way up through the adobes from the groundwater of that canale and had dissolved those adobes. So we're opening a couple of windows, and that's how we do it. Literally, Jess is cutting through the 2 layers of stucco. So here he is removing stucco. And keep an eye as we remove this small window of the 2 layers of adobe, because what we're really interested in here is the nails that were used to attach the original poultry wire on which the stucco was applied. If those nails are rusty, this high up the wall, it indicates that there has been moisture in that area, eroding those adobes. Watch all the dirt that comes out of the bottom of the window. That's this eroded mud plaster as a result of condensation, but the nails themselves are barely rusted at all. So that gave us an idea that liquid water had not gone up that far in the wall. That was a great relief. I'm going to show you a couple of the results of those window openings. Look at the middle of this window and you'll see there's a pencil right there. That pencil represents the initial survey hole that we put into that wall where we had absolutely no resistance. When we cut the window away, we could see that there had been some erosion of the adobe plasters, but a number of the original adobe plasters was still there. Dorothy Kreutzer, our conservation finishes surveyor, was able to identify those layers. So this number 1 represents the original mud plaster that was put on the surface. 2A and 2B indicate subsequent layers that were put on to repair that stucco, and notice how the color changes. There's a portion of a third layer here, and then you can see the 2 separate layers of cementatious stucco that make up the present wall. Now, when we cleared away those loose areas, here's what we saw. So you can see how thick that number 1 layer of adobe plaster was, or mud plaster was, with the hay inclusions in that plaster layer, which is fantastic. We can see the adobes underneath, but this is what I wanted to point out. This is a gap between 2 adjoining original 19th century adobes where the mud plaster was gone. And we were worried that that mud plaster had washed away as a result of water intrusion. When we went back and looked at the historic photographs by Maria Chabot in 1945 that Pamela Hawks had gotten from the Research Center archive, we could see that that hole was there in 1945. So what that indicates is that the workers didn't necessarily take the time to fill all the gaps in the historic wall. And this is an important feature. We need to understand where those structural gaps are. That can help us indicate areas we need to monitor for structural deterioration. This is the inside of the garage, and it's one of the areas where the original pink mud plaster still remains. So there's been no erosion here. It wasn't covered over with cement stucco. This is the original color of the exterior pink mud plaster. And I just want to point out that it matches the color of that number 1 mud plaster here. So originally, major portions of this building were this beautiful pink color in 1949 when O'Keeffe moved in. That's the weather station. And what I want to just end here is a kind of a 3-part summary of then what the challenges are to the preservation of the structure that we've discovered. So first, what we understand from the weather station and from Michael's analysis of all the storm and weather data is that the total energy at Abiquiu of storms, both summer and winter, the total energy has doubled in the last 10 years when we compare it to the energy of the last 30 years. So that means that the velocity and volume of wind, rain, hail, and snow, summer and winter, has doubled. And that increases lots of risks. The risk of wildfires, blowing embers from domestic fires that still occur in the valley because it's an agricultural region, and from down and damaged power lines. We also have to begin to worry about the capacity of the canales that move water off the roof. Those canales may not be large enough to drain the volume of water that comes from these increased energetic storms. We also have to worry about the third item, which is the vacuum forces of these stronger winds pulling the windows. They're nearly strong enough now to literally break the windows in the studio, and the sitting room, and in the kitchen, and in the bedrooms. So we need to really carefully do a survey of the window framing and the anchoring systems to determine if they need stabilization and repair. And we have to consider removable temporary storm covers when a high windstorm may be moving in. And then we have to realize that the home and studio needs its own emergency power source to keep up with critical fire detection, reporting, and suppression systems. Second major group of challenges that we need to address for the long-term preservation of this property there needs to be a major project targeted at fire detection and suppression systems, structural reinforcement, and replacement of electrical and plumbing systems. You have to remember that many of these utilities are 75 years old and reaching the end of their serviceable life. We've got old electrical wiring. We need to install aspirating fire detection and low volume mist fire suppression sprinklers throughout the structure so that if a fire accidentally occurs beginning on the roof line or in the interior, we have the earliest possible warning and we have a built-in suppression system. We also know that we have to tie together that large window wall now at the south-facing wall of the sitting room. When that window was put in, the structural integrity of that wall was greatly compromised, and we find that that end wall of the sitting room is actually beginning to move and create cracks. So we need to take this major opportunity to do structural repairs at the next roofing interval and tie that wall more structurally to the east and west walls of the sitting room. And we need to do the same thing with the west-facing room of the roofless room. That's this wall that you see on the left hand of this picture. That's the roofless room wall that is just barely tied into the walls on either end. So we need to do a better job to prevent lateral movement and damage to that wall. And then, of course, we need to sort of control the amount of moisture. This green area that you see here really is the acequia where irrigation water passes, and it saturates the ground outside that lower bedroom where we think we may have problems with a sinking foundation. So we need to isolate the inside walls of this acequia to prevent the moisture from capillary action moving towards the foundation of that area. And then our third set of changes is that we need to begin applying these new digital tools that we've discovered to use remote moisture sensors, to begin a complementary program of Adobe and structural monitoring so that we can keep track of the changes of the wall. So using data loggers in the walls, installing logging accelerometers to measure the movement of that south-facing wall in the sitting room and the lower bedroom and the roofless room, and then acquiring a thermal imaging camera so that we can begin a monthly imaging program and document the condition of the bond between that cement shell on the outside and everything that's going on behind it. And finally, acquiring this wonderful semi-quantitative resistance drill so that we can continue to monitor the density of the adobes, particularly where they meet the foundation. That's my talk. I hope this has been interesting. I hope you all got a sense of the discovery and the excitement that went on with this team, and we'll take questions. Shannon?
Thank you, Dale. That was excellent. So one of the first questions, just going back a little bit in your talk, can you observe condensation with the scope and the half-inch gap between the stucco and the mud plaster during the winter?
Great question. So I imagine that we will be able to see that condensation. We were doing this portion of the survey in June of last year, and so consequently there was no condensation there. The adobes were relatively dry, which was the good news. There's no capillary moisture coming up from the ground. But I imagine if we were to do that in the winter and even use a moisture probe, a digital moisture probe, we would likely be able to see that condensation on the inside of the wall. That's a great idea. Excellent.
So, and also we had a question about how and if did we collaborate with the Abiquiu community on this project?
Giustina, who is our manager at the Welcome Center in Abiquiu, has had a number of community meetings. The Welcome Center is really meant to be a kind of community center for the entire Abiquiu community, where they can have films, they can have children's programs. The community can do things themselves, not just George O'Keeffe programs. And I know that Giustina is also planning a whole series of meetings about the survey, about the preservation of the site, and get feedback as the Lopez family has always done with the impact of visitors coming to the site with our tour bus, and how that impacts the community. So just an ongoing series, not just one meeting, but a continual series of interactions with the Abiquiu community at the Welcome Center, and really understanding just the changing impacts with the community.
So, and I don't know if this was addressed in the talk, I don't think you got to this, but there's a question about flooring and the mud flooring and why visitors aren't allowed in some of those rooms.
Right, great question. O'Keeffe and Chabot settled on a number of original floor finishes. So for example, in O'Keeffe's bedroom, O'Keeffe really wanted the floor of the bedroom to be black. She talks about this in the letters that Pamela Hawks discovered, about how she wanted this black rubber tile that was inflammable or not flammable, and that she wanted this pattern in the floor, and that they decided cork would be a good finish for the kitchen. And so Chabot poured cement floors everywhere there was going to be cork flooring. But in a number of the historic rooms, the sitting room, the dining room, the lower bedroom, they decided to keep the original linseed oil coated mud floors and oxblood coated mud floors. Those floors are beautiful and soft, but they really are just mud. And the problem is that every time O'Keeffe walked across it, it broke the clay particle bonds, and creates dust, and it creates a pathway. And those floors have to be repaired every year, just with the foot traffic of 1 to 5 people. So it becomes really difficult. It would seriously damage the floor if we had tours of 8, 15 people going over it every day for the entire tour season. So we need to be very cautious about those floors, just so that you can see the experience of what an original mud floor, the softness, the velvety quality of that floor looks like, and what the experience is of being in that room. If we had this eroded pathway, it wouldn't have that experience.
Yes, thank you. So we also have a question about, how did you come to the decision to monitor the wall condition on a monthly basis?
That's a great question. So, this is sort of the first look that we've gotten with the inside of the walls. And so the thinking is, this is sort of a combination of Michael as the environmental engineer, Tony and Dave as sort of Adobe instructional engineers. And the idea is that if we do some monthly readings, so that we get a sort of threshold, a baseline of data every month, that once we have that baseline data and we really understand the sort of seasonal changes that the low-level adobes go and the higher-level adobes go through, and we begin to get that behavioral picture over the course of a year, then we can cut back. We won't have to do it eventually every month. We can probably get it down to 2-3 times a year. But initially, to get that baseline understanding of the entire structure, we're going to have to start, just because the seasons change, the weather patterns and the moisture content of the ground changes. Right now we've begun irrigation of the garden using the acequias. So even though the temperatures are going up and the snows and the storms have stopped, we have a huge amount of water coming into the south-facing side of the structure. So we need to understand the behavior of the entire structure as a system. And then once we have that down, I think we can do it far less frequently.
Excellent. And we have a question about the repairs to the destructive probes.
The windows.
Is that maintenance aesthetic and annual?
So, not sure I understand the whole question, but I'll take a stab at it. So where we drill the probe holes, yes, we fill those back in with mud plaster where there needed to be original mud plaster, and then a thin stucco finish, that last ½ inch with a thin stucco finish so it matches the surrounding surfaces. And we could go back into those. Those would probably be the holes where we put in the remote moisture sensors into that wall. It's an obvious location for those sensors. where we cut the large windows out to really understand how the whole wall was responding and why we had no resistance when we drilled those holes, those we've patched back up just the way they were done originally. So that is that we initially cover with adobe mud plaster right on top of that area. That's all totally reversible and permeable. And then the last finish, after that's fully cured, we did cover it with cementatious stucco again, so that it again matches and weathers the same way as the rest of that wall. Hope that answers that question.
Yes, I think it does. And then one final question, Dale, how did you come to be doing this work?
Oh my gosh. Well, we don't have enough time for that, but basically, even as a kid, the great interest that I had was the history of human ideas and the history of human technology. Whether it was about art or it was about structures, or when I was in high school, it was about Volkswagen cars. I want to know like how that got built and why those materials were selected. And that was always an interest of mine. So when I became an undergraduate at UC Davis, it became kind of clear that one could make a profession out of studying the human use of materials and methods throughout time by studying art and architecture. And conservation became just kind of my dream way of studying the tangible history and tying it to the intangible history of human ideas.
Thank you. So with that, we will wrap up. Thank you everyone for tuning in. And I just want to thank our members again who make these sort of events possible. And if you're not yet a member, we'd love for you to join us. Please consider joining. You can go to gokm.org to join the museum, become a member, or give a donation. We would really appreciate it. And our next online lecture, it's on our website. It will be presented by Ariel Potek, our curator of fine art on O'Keefe in New Mexico. And this talk will be posted online. You can look for it sometime next week. So thank you, everyone.
Thanks, everybody. Stay safe.